Good morning. We are starting 8.5, volume of pyramids. Now I want to, go ahead and write that title, but I want to, before we start taking the notes, go over to a chart. Yesterday we worked on volume of prisms. Now we're working on volume of pyramids. I want us to be sure we understand the relationship between the two. So if you look at this chart on the far left, we've got the base. So yesterday we talked about a triangular prism, a rectangular prism. We didn't really talk about a cube, but a cube is a square prism, right? But it has the cube is the more appropriate name. And then the meaning is talking about the base. So if it's a triangular prism, it's a three-sided triangle-shaped base, right? And then if look in the center, it says polyhedron. Polyhedron is the name of these three-dimensional figures. So a polyhedron is any face, or any face that isn't a base, is called a lateral face. So yesterday we talked about this being, that's a little big, this being a triangular prism because the bases are triangles. So those are the bases. The rectangles that connect those bases, again, we talked about this yesterday, those are the lateral faces. So a polyhedron is a three-dimensional figure, while we have a polygon, which is a two-dimensional figure. So this is a new vocab word for today. So yesterday we worked with all of the figures on the left side of this column. Today we're working with the figures on the right. So these are the pyramids, while these are prisms. So a prism has two bases. A pyramid has only one base. So a triangular pyramid has a base of a triangle, and then they all meet up to a single point. That's the apex at the top. A square pyramid, and this, when we think pyramid, or for me, I think Egypt, right? The pyramids in Egypt, and so it kind of gives me a perfect visual, and this is kind of what I think of when I think of those pyramids. So this is a square pyramid, and then down here we've got a rectangular pyramid. And again, there's only one base for the pyramid. There are two bases for the prisms. And then these are the nets over here to the far right. We're not going to spend a ton of time working with nets this lesson, so I'm not too worried about talking through that right this second. The other thing that I want to point out is especially look down here with this square pyramid and cube. If we put this square pyramid inside of this cube, and again, my drawing is not going to do it justice, but if we put one of these in here, this pyramid takes up about 1/3 of the space of that cube. So if we ended up putting two more pyramids in here, and then over here, kind of to the back, it would take up the entire volume of that cube. So if we know that the volume for a cube or a rectangular prism, or even a triangular prism, is V equals capital B times H, area of base times height, well, to find the volume of a pyramid, any pyramid, you know that since we can fit three of them in that figure, it's actually 1/3 of the area of the base times the height. Because it's so related to that original prism, it's just 1/3 of it. So it's the same formula multiplied by 1/3. And again, your formula is going to change depending on what kind of figure you're dealing with, right? If it's a triangular prism or pyramid, this base, this B is going to be 1/2 base times height of the triangle. If we're dealing with a rectangular prism or a rectangular pyramid, that area of base is going to be length times width. So that capital B will not be the same for every single figure, whether it's a prism or a pyramid. So keep that in mind. We'll break down the steps in just a second, but you've got to be very intentional about the breakdown of your formula. Alrighty, let's scoot over. Alright, so we just talked about this. The formula for volume of a pyramid is V equals 1/3 capital B times H. Now keep in mind it's super duper important that you have the capital V for volume, capital B, which means area of the base, let's see, and then lowercase h, which means height of the pyramid. So area of base. This means height of the pyramid. And if we were talking yesterday, that's height of the prism. Remember to multiply all of that by 1/3. The pyramid is related to the prism because it is 1/3 the size. Alrighty, so another kind of key point. Let's make this in another color. Do not forget that the capital B will change depending on the base of the figure. Super duper important. Do not get stuck doing the same formula for every single pyramid or prism. It will change. Alrighty, so again, pause if you need to, but I'm going to go ahead and move on to a few key vocab words. These are words that I actually just talked about, but in a polyhedron, and we're going to be doing a Quizlet next week with all of the vocab words from this section. We're not writing all of them down today, but polyhedron will be one of them. Lateral face, apex, so we'll get there. But in a polyhedron, any face that is not the base is called a lateral face. So up top, when we saw a triangular prism, the triangles, these were the bases, right? The rectangles that connect those bases are called the lateral faces. The lateral faces in our case, today we're talking about let me redraw this. Oh, that's not good, but that's okay. This would be the base. The rectangles that are meeting up at the common vertex, those are the lateral faces. The lateral faces meet at the common vertex, which is what I just highlighted at the top. The height of the pyramid is the distance from the vertex to the base, and it has to be perpendicular to the base. So right here, you would see a dotted line to the base, and you would see a right angle. That right angle is telling you that the vertex is distance from the vertex is perpendicular to the base. You have to see that right angle. I'll tell you, we're talking about the distinction of that now, because as we move forward, we're going to be looking at another formula where they'll give us the height of the lateral face. So if you'll notice the difference between my dotted line, which is height of the pyramid, and my kind of slanted line, that's my slant height, it is not the same thing. this one that I just drew right here, that is the height of the lateral face, not the height of the pyramid. So just be very careful. I don't think you'll see two heights in this section, but moving forward you will. So remember to give a distinction between those two. Alrighty. This needs to be highlighted, circled, squared, something so that you know how important it is. This is what we talked about up above. You must determine what kind of pyramid, then determine what formula is best for that base's area, then plug in for volume. So you always start with the same formula. The formula is V equals 1/3 capital B, area base, times height of the pyramid. And then it's saying you must determine what shape is the base. Well, if it's a triangle, it would be 1/2 base times the height of the pyramid, times 1/3. But if it were a rectangular pyramid, it would be length times width instead of 1/2 base times height. So be very careful. Alrighty. Find the volume, example 1, find the volume of the pyramid, round to the nearest tenth. So our original formula that we're going to write down every single time is this V equals 1/3 capital B times H. Remember, do not drop your variables as you're writing because you will need them. When we get to example 3 and 4, you will need them. So get in the habit of holding on to them as you work through the problem. So let's first figure out what kind of pyramid we're dealing with, right? So we are dealing with a rectangular pyramid. So this area of base, I'm going to do length times width. And I'm going to multiply it by the height of the pyramid, and multiply by 1/3, and that all equals the volume. I'm going to do that for every single problem. Now, the next step is to label what we know. So I'm going to write down the volume, I'm going to do the length, the width, and the height. So it says find the volume, so we don't know the volume, so I'm going to leave that blank. But the length of the base is 3.2. The width of the base is 1.4. And the height, again, you see that dotted line, it's got the right angle. It's going to the center of the base up to the apex is 2.8. So I'm going to label all of that first, and then I'm going to plug in what we know. So I don't know V, so I'm going to keep V. 1/3 times, my length is 3.2, my width is 1.4, times my height, 2.8. Alright, B equals 1/3. Let's do 3.2 times 1.4 first. We will get 4.48. Remember, do not round until the very, very end. Then 4.48 times 2.8. I multiply by the 1/3 last. Equals 1/3 times 12.544. Now, be sure in your calculator, do not convert 1/3 to a decimal. You have to multiply that 12.544 times 1/3. So depending on what kind of calculator you have, do 12.544 times, and then you can do parentheses 1 ABC 3 close parentheses, or you can do times parentheses 1 divided by 3 close parentheses. Either way, in this case, you should get V equals 4.1813 repeating. Now, keep in mind it said round to the nearest tenth. So, my final answer here would be 4.2, and it is inches cubed. Keep in mind volume is cubed. So 4.2 inches cubed is our final answer. Alrighty, let's scroll down to example 2. I changed the numbers for this one. So go ahead and just use the numbers that I crossed out and rewrote, the 12, 4.8, and 6.1. And let's call these inches. Sure. Alrighty. So first we need to figure out what kind of pyramid we're dealing with. And the pyramid in this case is a triangular pyramid. So the capital B, area of base, is 1/2 base times height, and it's base of the base, and it's height of the base. So times height of the pyramid times 1/3 equals V. And I'm going to label what we know. So I've got V, I've got B, I've got H, and I'm going to write H of the height of the base, and I'm going to write height of the pyramid. In this case, we are multiplying everything together, so if you got those mixed up, it wouldn't be a huge deal, but moving forward, it will be a big deal, so just kind of keep that in mind. All right, so it says find the volume, so we don't know the volume, so I'm going to leave V blank. B, the base is of the triangle, is 6.1. The height of the base is 4.8. The height of the pyramid is 12. Alrighty, so we've got everything labeled, which you will need to do tonight on your homework. When you look at my answer key, you will see all of that detail included. And let's plug in what we know. I don't know V, so I'm going to put V there. I'm going to keep it, right? I don't drop it. 1/2. My base is 6.1. Height of the base is 4.8 times height of the pyramid, which is 12. Alrighty, so 6.1 times 4.8 and is 29.28 times 1/2 is 1/3 times 14.64 times 12. We do 14.64 times 12 first. So V equals 1/3 times 175.68. Now I'm going to multiply that by the 1/3. Again, keep the 1/3 a fraction. Do not convert it to a decimal. Do not convert it to a decimal. You will get 58.56, and it says round to the nearest tenth. So it is 58.6 inches cubed. Alrighty, so the first two examples, as long as you know and you fill out this side section, what you're dealing with, and that you get both of these formulas written down, it's kind of just plugging in and, plugging into your calculator. So plug in what you know and then type into your calculator. These first two are pretty basic. The next two, instead of asking to find the volume, instead it says find the height. So we're going to start with the same 3 steps. So we're going to write our original formula, which is V equals 1/3 area of base times height of the pyramid. Then we're going to break it down based on what figure we're dealing with. And then we are going to label what we know. So let's go ahead and start that. So first, what do we know? What kind of pyramid are we dealing with? We are dealing with a rectangular pyramid. So I'm going to break down my formula. Since it's a rectangle, the area of the base is length times width times height of the pyramid is 1/3. V equals 1/3, right? Length times width times height. Now, let's label what we know. We've got V, we've got length, width, and height. So the rectangular pyramid shown has a volume of 90. Okay, so we know volume, so I'm going to plug in here. And then it says find the height. So we also know height of the pyramid. We also know that the length is 9 width is 5, and we don't know the height, so I'm going to leave that one blank. All right, so I'm going to plug in what we know. We know V is 90. We know the length is 9, width is 5, and we don't know the height of the pyramid, so I'm just going to keep H as my variable. I'm not going to replace it with an X. Keep the one that you're dealing with in your formula. All right, and since we're trying to find the height, we are eventually going to have to use inverse operations to isolate that variable. However, we've got to simplify before we do that. So we've got 9 times 5 gives us 45 equals 90. I'm going to do 1/3 of 45, which gives us 15. So 90 equals 15 times H. Or you can just write 15H, which is fine. Now to isolate that variable, since we're dealing with multiplication, we're going to divide both sides by 15. And 90 divided by 15, we get 6 equals H. Alright, so our final answer is 6 inches. Now it's not cubed because we're dealing with height, not volume. If it asks us to find the volume, it would be 6 inches cubed, but in this case it's just height. That is our final answer. Alrighty, example 4. Again, we start with our original formula, V equals 1/3 area of base times height. And then we break it down depending on what type of pyramid we're working with. So we've got a triangular pyramid, so area of the base, it's going to be 1/2 base times height of the prism times 1/3 equals V. And then I'm going to label what we know. V base, this is height of the base. This, the second H, is height of the pyramid. Alright, so it says the triangular pyramid has a volume of 44 cubic meters. So 44 will be my volume. It has an 8-meter base. Alright. A 3-meter height. Find the height of the pyramid. So I'm going to leave that one blank and it'll stay H. So I'm going to plug in what I know. 44 equals 1/3 8 and 3 times H. Alright, 1/2 times 8 is 4, times 3 is 12. 1/3 of 12 is 4. Divide both sides by 4 in order to isolate that height, isolate that variable. 44 divided by 4 gives us 11 equals H. So our final answer is 11 meters. Alrighty, so now we are moving into the got it's. So go ahead and pause the video and work through the got it's on page 654 and 655. It's just A, B, and C. Oh, there is a C. So A, B, and C. Pause the video, work through it, then check your work with my work. Again, show all necessary steps. I will tell you now that you are turning in your homework for tonight. I am going to be checking that you are showing all of your work. There are details and instructions on how to do that on Google Classroom under the NTI Day 325 materials. Obviously, if you have any questions, let me know. But you are turning in tonight's homework. You're scanning it in. Alright, so pause, then go ahead and work through. I'm going to go ahead and start. It says, got it, A. Find the volume of a pyramid. So I'm going to go ahead and start with my original formula. V equals 1/3 capital B times H. Volume of a pyramid that has a height of 9 centimeters. And a rectangular base. So I know that I'm going to break this down to length times width. So V length, width, height. I don't know my b, so I'm going to leave it blank. It says height of 9 centimeters, rectangular base with a length of 7, width of 3. Length is 7, 21. So 1/3, of 21, we get 7 times, oh, I am losing my mind. I am not finding h. I need to plug in what we know. Times 9. So 1/3 times 21 times 9. So 21 times 9, we get 189. Times 1/3, we get 63. V equals 63, and it is centimeters cubed. Alrighty, got it, B. Now we are finding the height. So it says a triangular pyramid. So I'm going to start by writing our original formula. B equals 1/3 capital B times h. Triangular, so I'm going to do 1/2 base times height of the pyramid. So triangular pyramid has a volume, so I'm going to label what we know. B equals 840 base, height of base, height of pyramid. So height of base is 21. The base is 20 inches, base length. And then it says find the height of the pyramid. Alright, so I'm going to plug in what I know. I know my volume is 840, 1/3 times 1/2, the base is 20, 21 times height. So 1/2 times 20 is 10. 10 times 21 is 210. 210 times 1/3 is 70. 70 times h. Divide both sides by 70 in order to isolate that h, isolate that variable. And 840 divided by 70 gives us 12. And it is 12 inches. 12 inches is our final answer. Alrighty, got it. C. Rectangular pyramid. Okay, so I can start out with my original formula. B equals 1/3 capital B times h. It said rectangle, so I'm going to break this down to length times width. Rectangular pyramid has a volume of 525. It has a base, so length and width and height. It has a base of 25 feet by 18 feet. So 25 by 18, and we don't know the height. Alrighty, so I'm going to plug in what we know. 525 equals 1/3 times my length is 25, width is 18, times the height. Alright, 25 times 18, we get 450. $450 times 1/3 gives us 150. Divide both sides by 150 in order to isolate that variable, which is our height. And 525 divided by 150 gives us 3.5. So our final answer in this case is 3.5 feet. Alrighty, So be sure for every single problem, you should be showing this much work. You have to be showing all parts. Tonight's homework, I did not grace you with my beautiful drawings on each question. So just be sure you know which visual I'm looking at, why did I label it what I labeled it. And again, you are turning in your work. So I am seeing all of this. I should see 6 problems that look just like this. Alrighty, again, let me know if you have any questions.